Welcome to the deep dive. Today, we're really digging into where artificial intelligence research is headed, both now and, looking ahead.
That's right. We've got this AAAI 2025 presidential panel report. Just came out last month, March 2025.
And the cool thing is, it's not just one viewpoint. They actually surveyed, 475 AI folks from academia, corporate research?
Exactly. So it gives us a pretty broad snapshot of what the community itself is thinking across a whole range of topics.
Right. We're talking AI reasoning, trustworthiness, that's a big one. Agents, how we even evaluate AI, ethics, safety. The list goes on. Embodied AI, even AGI.
It covers a lot of ground.
Yeah.
And the survey data is gold because it shows where there's consensus, but also, where the researchers themselves kind of disagree.
Yeah, that's what we want to pull out today. Those key trends, maybe some surprising insights, and definitely those areas of debate. So for you listening, if you like getting up to speed quickly and seeing different sides of things, this is for you.
We're aiming for those aha moments without getting lost in the weeds.
Totally. We'll start with something fundamental. How AI systems reason, especially those big language models everyone's talking about.
And then, crucially, how we make them trustworthy and, factual, which is proving harder than it sounds.
Okay, let's dive in. AI reasoning. The report frames this as like a core part of human intelligence, right? Taking what you know and figuring out something new.
Pretty much. Either formally, like logic, where the answer is guaranteed correct, or more plausibly, like making educated guesses. AI's been working on this for ages.
With techniques like SAT, SMT, probabilistic models, things that are actually used out there in the real world.
Yeah, they're foundational for a lot of applications.
But then we have the LLMs, the large language models. They seem to reason, sometimes quite impressively. But the report says maybe not reliably enough.
Well, yes. There's a gap.
Yeah.
LLMs show advancements, definitely.
Yeah.
But for things like autonomous AI agents, you need reasoning that's guaranteed correct, or at least much deeper and more verifiable than what we often see now.
So that leads to this research push on large reasoning models and neurosymbolic approaches. What's that about?
Think of it like combining the best of both worlds. Neural nets are great at pattern recognition, learning from data, kind of like our intuition. Symbolic AI is strong on logic, rules, step-by-step deduction.
Like traditional programming.
In a way, yeah. More structured.
Mm-hmm.
The idea is that putting these together, neurosymbolic, could be the key. And the community seems to agree.
How much?
A lot. 76.9% surveyed. I think integrating learning and reasoning is very important, huge majority. And explainability, verifiability, also super high, over 71%.
That's a strong signal. And what about symbolic AI's role on its own? Is it fading away with deep learning?
Not according to this survey. It's quite interesting. 61.8% think we'll need at least half symbolic techniques to get to human-level reasoning.
Wow, half.
Yeah, and almost a quarter think we'll need 75% or more symbolic stuff. So despite the LLM hype, those classic methods are still seen as vital.
And the report mentions we already have AI achieving superhuman reasoning in some areas using these formal methods.
Right. In specific fields like science, math, engineering, even AI safety verification. These aren't LLMs. They're often highly specialized symbolic systems. They prove things mathematically.
So it raises some big questions then, like what is reasoning for an AI? Can we trust LLM reasoning? Is symbolic AI here to stay?
And critically, how do we blend them effectively? How do we build these neurosymbolic systems that are both powerful and reliable? That seems to be a central challenge.
Okay, so reasoning is complex, but then the report flags something else as the single biggest topic right now.
Factuality and trustworthiness.
Exactly. Improving that is apparently the top priority. But here's the kicker. The scientists surveyed are actually pretty pessimistic about solving it quickly.
Yeah, that's a sobering takeaway. The people building it see it as a hard, long-term problem.
We should probably define those terms. Factuality is.
Basically, avoiding making false statements. Not hallucinating, as they say with LLMs, sticking to the facts.
And trustworthiness.
That's broader. It includes factuality, but also things like understandability. Can we see why it did something? Robustness, does it break easily? And alignment, does it follow human values?
The report mentions garbage in, garbage out, but says generative AI is different because it reconstructs things, leading to imaginary stories.
Right. It's not just retrieving information, it's generating it based on patterns it learned. Sometimes those patterns lead it astray. Fine-tuning helps in specific areas, but doesn't eliminate the problem.
So how are researchers tackling this? What are the main approaches?
Several things. Fine-tuning, especially using human feedback, RLHF, retrieval augmented generation, or RG,
That's the library card idea, giving it access to reliable info.
Pretty much, yeah. Letting it look things up before answering. Also, giving AI tools like calculators, databases, even those formal reasoners we just talked about.
And things like rule-based constraints, chain of thought prompting.
Yeah. Chain of thought, where you make the AI explain its steps, helps with both factuality and understandability, which links back to trustworthiness.
Makes sense. If you can see its reasoning, you might trust it more.
Exactly. Developing more inherently interpretable models is another angle. And letting models express uncertainty, saying, I don't know, or I'm not sure, that also builds trust.
What did the community survey say about this? Is it a priority for them personally?
Over 75% said factuality and trustworthiness are relevant to their own research. So yes, it's widespread.
And what do they think will work best?
For factuality, they pointed to new neural net architectures and external fact-checking tools like RAG and using reasoners.
And for trustworthiness?
Again, new architectures, but also models that can actually explain their reasoning process.
Interestingly, giving AI a human-like personality, that wasn't seen as important for trust.
No. The consensus seems to be that trust comes from reliability and transparency, not from seeming friendly or human-like.
Which makes sense. But they also felt the definition of trustworthiness itself is fuzzy.
Yeah, 59% found it ill-defined. And most don't think factuality or trustworthiness will be solved anytime soon. It highlights the deep challenges here.
Okay, shifting gears a bit. Let's talk about AI agents and multi-agent systems, or MAS. The report kind of looks back at their history.
Yeah, it mentions an initial boom, lots of excitement, but then questions about whether they were finding enough real-world uses beyond just academic research.
But they have found uses, right? You mentioned some earlier.
Absolutely. Despite maybe the grand vision of agents collaborating everywhere being slow to materialize, MAS have had real successes. Security games at airports, high-frequency trading.
Agent-based modeling for economics and pandemics, too.
Exactly. Those are significant applications. But the original vision of agents working together seamlessly, like in a simulated society, that's still mostly in the social simulation research space.
But individual agents, dialogue agents like Alexa or Siri, they're everywhere now.
They are. And their roots are in that early agent research and natural language processing. They power call centers, virtual assistants, even some home robots helping with tasks.
Within MAS, there was this thing called MRRL, multi-agent reinforcement learning.
Right. It became a big subfield. Basically, getting multiple agents to learn cooperative or competitive strategies through trial and error. The report notes it might have grown partly because it was easier to set up experiments for.
But it also questions if it has a clear direction or application.
Yeah, it raises a point about its unifying vision. Where is MRL ultimately heading? What are the killer apps?
Now, the new challenge seems to be integrating the latest generative AI, the LLMs, into these agent systems.
That's a major focus now. How do you embed these powerful but sometimes unpredictable Gen AI agents into multi-agent setups without messing things up? How do you get them to negotiate, collaborate effectively, ethically, safely?
And scaling them, making them transparent. Sounds tough.
It is. Developing the architectures to support this is a big research challenge.
How does the community feel about agentifying LLMs, putting them into agent roles?
It's a mix. Critical but open? Maybe. There are definite concerns. Theoretical guarantees, can we prove how they'll behave? Computational costs, they're expensive to run. Grounding, connecting them to the real world. Alignment, making sure they do what we want. Communication.
So lots of hurdles.
Definitely.
Yeah.
Some researchers even question if LLMs are always the right tool here, suggesting we might need frameworks that better integrate symbolic reasoning or have more structured governance. It's not just plug and play.
That makes sense. You can't just drop a powerful new tool into an old system and expect it to work perfectly, which leads nicely into AI evaluation.
A really critical piece.
The report says organizations are hesitant to deploy AI widely because of risks, right? Hallucinations, data leaks, lack of safety guarantees.
Yeah, the potential downsides are real, and they make companies cautious.
And evaluating AI is just hard.
Inherently complex, yes. Especially for systems that can do many things and keep learning. You need a balanced approach, focusing on realistic use cases, not trying to test everything. Transparency is key.
What about red teaming?
That's mentioned as a valuable complementary technique. Basically, actively trying to break the system to find vulnerabilities before they cause harm in the real world.
So looking forward, evaluation needs to cover capability, does it work? Usability, is it transparent, controllable? And adherence to rules, legal and ethical.
Those are the key dimensions. And frameworks are being developed, like the EU's Trustworthy AI framework, to help standardize this.
What are the big research needs in evaluation?
Better ways to monitor AI over time after deployment. How to assess the safety of agentic systems acting in the world. Increasing model transparency. Rethinking human-AI interaction evaluation, maybe beyond the Turing test. And understanding the trade-offs, you often can't maximize all evaluation dimensions at once.
Okay, but here's that disconnect again. The report stresses caution, but the survey showed only 58% of researchers thought organizations would be reluctant to deploy without better evaluation.
Yeah, it suggests a potential gap, maybe a push towards application that's outpacing our ability to fully validate these systems. It's definitely something to watch.
A bit concerning, perhaps.
Potentially, yes. It highlights the need for better communication between researchers and those deploying the technology.
Let's shift focus to AI ethics and safety. As AI gets more powerful, the responsibility grows, right?
Absolutely. The choices researchers and developers make have real societal consequences now.
Ethics and safety, they overlap but aren't quite the same.
Right. They both relate to ensuring AI benefits humanity, but maybe safety focuses more on preventing direct harm, like a self-driving car crash, while ethics covers broader issues like fairness in algorithms or manipulation by recommendation systems.
And the report brings up the alignment problem. AI pursuing goals we didn't intend.
Yes. The concern is that a powerful AI might develop instrumental goals like acquiring resources or self-preservation in ways that conflict with its original purpose, potentially leading to negative outcomes. This used to be seen as sci-fi, but it's becoming a more mainstream concern.
So the key questions are, when do we address ethics and safety? Is fail-safe AI possible? How do we spot warning signs? What technical fixes can help?
Exactly. And it delves into ethics review in AI research. Traditionally, AI projects haven't gone through the same kind of ethics boards, IRBs, as, say, medical research.
Should they?
The report suggests maybe they should, especially when training on broad data sets scraped from the web or when building systems aimed at vulnerable groups like children. And we need people trained to actually do these AI ethics reviews.
It really sounds like we need more people involved than just computer scientists.
Definitely. Interdisciplinary research is crucial. Can a single alignment technique even address all the diverse ethical and safety concerns? Probably not.
What did the community prioritize? What are the biggest ethical worries?
Misinformation came out on top, with 75% citing it. Then privacy, around 59%, and responsibility accountability, around 49%.
Were there concerns about resources?
Yes, a lack of resources for AI ethics research was noted by almost 58%.
And how do they think we should tackle safety?
Multidisciplinary approaches were strongly favored, 85%. Technical research is still key, 72%, but regulation, 61%, and education, 74%, are also seen as vital strategies. Most believe we need to coordinate efforts addressing both short-term risks and potential long-term concerns.
Okay, let's move to embodied AI. This is the idea that intelligence needs a body interacting with the world.
That's the core concept, yes.
Yeah.
Intelligence emerges from that continuous loop of sensing, acting, and learning within a physical environment. It's crucial for agents that need to operate in the real world, not just process data.
And robots are the main platform for this.
They're seen as good platforms, yeah. Embodied AI is presented as a kind of third paradigm, distinct from purely representation-based AI or purely learning-based disembodied AI.
Why is the real world so important here? Can't AI learn from videos?
It can learn patterns from videos, but the argument is that passively observing isn't enough to learn how to act effectively or to gain the deep, implicit, common-sense knowledge that comes from physical interaction. Embodied agents can test hypotheses, learn cause and effect directly.
What are the current trends in EAI research?
Big emphasis on robots learning via reinforcement learning, both in simulation and the real world. Adapting LLMs to help robots generate plans. Also trying to build causal models of the world by interacting with it.
But there are still big open questions.
Oh, yeah. Is standard end-to-end training enough? Do we need a better synthesis of AI and control theory from robotics? How do we best leverage pre-trained models like LLMs for embodied tasks? How realistic do simulators need to be? And crucially, safety. How do we guarantee embodied agents won't cause harm?
Building C-3PO is still hard then.
Very much so. A general-purpose, capable physical robot is still a grand challenge.
How relevant did the AI community find embodied AI?
Pretty relevant. 74% said it was somewhat relevant or very relevant. 75% agreed embodiment is important for AI's future.
And they preferred real robots over simulation.
A strong majority, 72%, felt robotics was useful or essential, not just simulation. Interestingly, artificial evolution wasn't seen as a particularly promising path by most, only about 35%. Next up, AI and cognitive science. The report argues for rebuilding bridges.
Yeah, AI originally grew out of cognitive science alongside psychology, linguistics, neuroscience, anthropology. But it's drifted over time, become more engineering focused. The report suggests reconnecting would be beneficial for both sides.
Where's the synergy? What could they learn from each other?
AI could learn from how humans learn so efficiently from limited data, how we reason robustly even with incomplete knowledge, how we build explainable mental models. Cognitive science could use AI models as tools to test theories about the mind.
Specific areas mentioned.
Human-like learning and reasoning is one. Cognitive architecture is trying to build integrated systems that model perception, cognition, action, and social intelligence understanding and interacting in social contexts.
What are the key research questions here? How can AI reason better with incomplete knowledge, like humans do? How can we integrate foundation models into broader cognitive architectures? Can we develop better benchmarks that truly capture the range of human cognitive abilities? And for social AI, how do we get data ethically and create good interaction benchmarks?
It sounds like a push to make AI less alien, more grounded in how natural intelligence works.
I think that's a fair way to put it.
Is the AI community already engaging with cognitive science?
The survey suggests yes, quite a bit. 82% said they're influenced to some degree by other cognitive science fields. Psychology was the most cited, followed by neuroscience and linguistics. So the connections are there, but perhaps could be stronger.
Okay, let's talk about the nuts and bolts literally. Hardware and AI.
A crucial link. The report emphasizes that AI progress has always been tied to hardware progress. Algorithms adapt to hardware, hardware evolves to accelerate dominant algorithms.
And right now, that means neural networks and hardware like GPUs and TPUs.
Exactly. That co-adaptation is happening right now. Algorithms that scale well on current hardware get adopted. Hardware makers focus on speeding up the key computations for those algorithms.
Major challenges are energy and throughput for these huge models.
Yes, finding ways to represent numbers more efficiently, exploiting sparsity in computations, and maximizing parallelism are key strategies.
Mhm.
But edge deployment running AI on phones, sensors, cars remains really difficult due to power, heat, and memory constraints.
The report mentions a history here, AI for designing hardware, specialized chips for symbolic AI.
Right, like Deep Blue for chess. Hardware acceleration wasn't just for neural nets initially. It helped probabilistic methods too. But the current deep learning boom is undeniably linked to specialized accelerators. They quote, "Deep learning was enabled by hardware, and its progress is limited by hardware," really sums it up.
So what are the research challenges going forward in hardware?
Adapting hardware for novel number representations like lower precision math that saves energy without hurting accuracy too much. Seriously, tackling edge deployment power, thermal management, memory, handling diverse components, and using AI itself more effectively to help design and optimize the next generation of hardware.
It's a feedback loop, isn't it? Better AI needs better hardware. Better hardware enables better AI.
Precisely. They drive each other forward.
Let's move into AI for social good, or AI for SG. This prioritizes impact.
Yes, measurable societal impact, especially for vulnerable groups and in areas that haven't traditionally received much AI R&D attention.
And the approach is different, more ethical, interdisciplinary.
Very much so. Ethics, fairness, real-world benefit are front and center. It requires deep collaboration with domain experts and the communities actually affected. It's not just about optimizing an algorithm, it's about solving a real problem responsibly.
Has this area grown recently?
Yes, driven by general AI advances and more funding and attention at conferences. Interdisciplinary work and ethical considerations are becoming standard practice within AI for SG.
Current trends include cloud platforms, explainability, localized solutions.
Right. Leveraging the cloud for reach, making systems understandable, designing solutions that fit local contexts and are sustainable, and exploring how foundation models can be applied for social good are all active areas.
What are the main hurdles for AI for SG?
Designing systems that are truly relevant that requires participatory design with the community. Ensuring sustainability and scalability, especially in low-resource settings. Bridging the skills gap between traditional AI training and what's needed for social impact work, and importantly, avoiding techno-solutionism.
Techno-solutionism.
The trap of thinking technology alone can fix deep social problems, sometimes driven more by PR than genuine impact. AI for SG tries to avoid that by focusing on holistic solutions.
How did the community view AI for SG?
Most found it relevant, but they highlighted barriers like the difficulty of field testing, scaling up projects, connecting with the right organizations, defining the problem clearly, and assessing readiness for AI adoption.
What did they see as key for success?
Money and data were seen as critical for scaling, along with strong partnerships and technical support. Success metrics focus on actual improvement outcome, sustainable results, and adoption rate. Real-world results matter most.
Now, AI and sustainability. This seems like a double-edged sword.
It really is. AI can help with sustainability, but AI itself consumes resources, particularly energy and water for computation.
And that demand is growing fast with generative AI.
Significantly. Data centers already use about 2% of global electricity, and AI's share of that is rising rapidly, especially in AI hubs like the US and EU. The water usage for cooling is also becoming a concern.
But AI can also help sustainability.
Yes, definitely. It can improve prediction and optimization in energy grids, water management industry, logistics, reducing waste and emissions. Examples include better hydrological forecasting, detecting leaks, climate risk management, wildlife monitoring. Lots of potential applications.
Is it easy to tell if AI's net impact is positive or negative?
No, it's actually very difficult. Data is often limited, and assessing the true impact of AI interventions is complex. You have the direct energy-water use of AI, but also the indirect effects, positive or negative, on the systems it's applied to.
So we need better analysis, scenario planning.
Exactly. Policy-relevant scenario analysis is needed to understand the full footprint and guide decisions. And we need to actively design more resource-efficient AI better models, specialized hardware, carbon-aware computing infrastructure.
Is the AI community decided on whether the benefits outweigh the harms?
The report says the community is divided on that question. But there's agreement that optimizing logistics and transportation is a major opportunity for AI to contribute positively.
Let's talk about AI for scientific discovery. This sounds revolutionary.
It has the potential to be, yes. The report describes AI accelerating the entire scientific process, from gathering knowledge to designing and running experiments, analyzing results, and forming new hypotheses.
It can be an assistant, a collaborator, or even an autonomous scientist.
That's the spectrum. From tools that help humans, like AlphaFold 2.
The protein folding breakthrough, Nobel Prize winner.
That's the one. A prime example of AI as a powerful tool, to more collaborative systems, all the way to the idea of an AI driving the discovery process itself.
How does AI help discover things humans might miss?
By being able to systematically explore vast hypothesis spaces without human biases. And an AI-centric approach changes how we think about data. All data becomes potentially valuable for training and generating insights, not just the data confirming a specific hypothesis.
What are the challenges in using AI for science?
Communication is one, bridging the gap between AI outputs and human scientific understanding, dealing with ambiguity, incorporating common sense. Data quality is another. Scientific data can be noisy, sparse, or hard to reproduce, which can be tough for AI.
What's the outlook from the community? Where will AI have the biggest scientific impact?
Biology came out on top in the survey, 47%. As for major breakthroughs, like a Nobel-worthy discovery made by AI, opinions varied. 13% said never, but 11% thought maybe this decade, and 45% thought by the 2050s. So considerable optimism there.
Okay, the big one. Artificial General Intelligence, AGI, the quest for human-level AI.
The original dream, in many ways. Since the 1956 Dartmouth workshop, the idea of simulating all aspects of intelligence has been there.
Though much research focused on narrow AI components.
For a long time, yes. But the goal of human-level intelligence resurfaced more strongly in the early 2000s and is now explicitly pursued by some major players.
Does everyone agree on what AGI even is, or if it's desirable?
No clear consensus on the definition. And the report questions if simply matching human abilities across the board is the right goal, suggesting focused tools might be better near term. But AGI is a canonical goal for some influential labs.
Recent progress seems to be fueling the AGI discussion again.
Definitely. Rapid gains in perception, translation, generation, and now reasoning have made it feel more tangible to some. Multimodal models, embodied AI, it all feeds into this picture of more general capabilities.
What about this test time reasoning, deliberation?
That's an interesting advance. AI systems taking more computational steps at inference time to explore possibilities, like a chain of thought, mimicking more deliberate human cognition. It requires much more compute, though.
But there are still significant gaps, things AI struggles with.
Oh yes, math word problems involving imagery, complex spatial reasoning, fine-grained image understanding, long-term planning, especially physical planning with humans involved, these remain really hard.
So, what are the key research directions towards potentially more general AI?
Exploring architectures beyond transformers, they have limitations. Achieving better generalization, performing well on data different from training data, and enabling continual learning, adapting over time without forgetting past knowledge. These are fundamental.
And the societal side becomes even more critical with more capable AI.
Absolutely. Understanding impacts, safety, governance, monitoring these become paramount as capabilities increase.
What did the community think about AGI ownership and research pauses?
Strong majority, 82%, felt privately developed AGI should be publicly owned. But most, 70%, opposed halting AGI research until safety is fully figured out.
Do they think scaling current methods will get us to AGI?
Mostly no. 76% doubted that just making current models bigger is the path to AGI.
The report also warns about hype, using AI too broadly.
Yes, treating AI as a monolith leads to overgeneralizing specific breakthroughs and fuels hype cycles, which can even influence policy inappropriately.
And it strongly advocates for research diversity, not just neural nets.
Critically important. Supporting non-neural approaches, hybrid approaches, totally new paradigms is seen as essential to overcome current limitations and foster real innovation. There's concern that the intense focus on deep learning might stifle other promising avenues.
Did the community agree on needing diverse approaches?
Overwhelmingly, 92% thought research beyond neural nets is relevant. 94% thought at least a quarter of AI research should be hybrid, neural plus other. And 86% thought at least a quarter should be purely non-neural. Huge support for diversity.
Moving beyond the AI community itself, the report calls for broader perspectives.
Yes, integrating insights from social scientists, ethicists, policymakers, domain experts in fields like biology, law, business is seen as crucial for responsible development and understanding AI's impact.
Why is this so important now?
Because AI isn't just an engineering problem anymore. It's reshaping society, culture, economics, ethics. Addressing bias, privacy, governance requires perspectives from humanities and social sciences to align AI with human rights and values.
So AI is becoming a tool in many other fields.
Exactly. Healthcare, law, business, they're increasingly using AI, which drives demand for accuracy and explainability, fueling research in areas like XAI, explainable AI.
And we need better ways for these different experts to collaborate.
Yes, developing intelligent support or tools to facilitate interaction between AI researchers and domain experts is highlighted. Key areas for collaboration include legal frameworks, cultural adaptation, public education, domain-specific tools, and AI-enabled collaboration platforms.
The report also mentions a strain on universities, the demand for AI courses.
A big one. The surge in student demand is overwhelming many computer science departments. Even with hiring efforts, it's a real capacity challenge.
Finally, let's touch on the geopolitical aspects. AI is changing global power dynamics.
Massively. It's influencing economics, national security, governance structures. Nations are competing for AI dominance.
So it's becoming very international investment, collaboration, regulation.
Yes, but it's also a geopolitical battleground. While there's growing international coordination, OECD, UN efforts, AI safety summits.
It's like the UK, Seoul, and French summits.
Exactly. They show recognition of the need for global governance.
But national interests differ, approaches clash.
Precisely. Different regulatory philosophies, economic competition, like the US Stargate Initiative or EU Invest AI, security concerns lead to tensions. The disagreements at the recent AI Action Summit highlighted these fractures.
So without unified governance, regulation stays fragmented.
That's the risk, which could worsen security issues, inequality, instability. AI is now a key factor in national power, influencing trade, military strategy, diplomacy. US and China lead, Europe emphasizes ethics, some regions use AI surveillance heavily. It's complex.
What are the research areas where geopolitics and AI intersect?
AI for monitoring supply chains, algorithmic trade policies, AI in cybersecurity and defense, including autonomous weapons and biosecurity. Also, critically examining techno-solutionism in national AI strategies.
Should AI scientists get involved in policy?
The survey showed a majority, nearly 50%, think yes, they should engage. And there was strong support for international governance efforts.
Okay, so wrapping this all up, we've covered a huge amount of ground from this AI report and survey. What are the big takeaways?
Well, the quest for AI that can truly reason, that's factual and trustworthy, is clearly paramount. And integrating different approaches like symbolic and neural seems key.
AI agents are evolving successes in niches, but challenges remain for broad collaboration and integrating Gen AI. And evaluating these powerful systems needs much better methods.
Right. Ethics and safety are now central, not optional extras. Embodiment and cognitive science offer paths to more grounded, maybe more human-like intelligence. Hardware remains the bedrock, enabling but also limiting progress.
AI for social good and sustainability present this dual challenge, huge potential benefits, but also significant responsibilities and resource demands.
Science is being transformed by AI tools, and AGI, while debated and maybe distant, continues to drive research and raise profound societal questions.
And underpinning all of this is the need for broader collaboration beyond just AI experts and the complex geopolitical landscape AI now operates within.
It's a lot. A rapidly moving, incredibly impactful field with deep technical challenges and huge societal implications.
So here's a final thought for you listening. Given everything we've explored, the technical hurdles, the ethical dilemmas, the global competition, the differing views even within the AI community, what do you see as the single most pressing priority for AI research moving forward? What's the one thing we absolutely need to get right to ensure AI benefits everyone? Is it cracking reasoning and trust, nailing down safety and ethics, or maybe establishing global rules of the road first? Something to ponder as AI dives even deeper into our lives.
Drop it, go. Well, guys, I want the black car.